Hello, welcome to the 4coder Lexer show. Shoot, I think we're on episode 26. Who even knows? I should have looked that up. Anyway, doesn't matter. We have stuff to do. So the next step of this is going to be making sure that the stuff we're generating actually works. And I know there's a couple of things I haven't added in. Anyway, so there's the type checking stuff I haven't done yet, but that doesn't actually influence whether or not this works. But I also haven't actually implemented the delimiter match transition yet. So there's at least one part of it that won't run correctly, but I want to make sure that everything we've built so far, like that we generate so far, actually builds before I move ahead. So let me see what I have to do to get there. Right now we output some code. What code do we output? So one thing I want to do that I guess I didn't do before is if I successfully open up all the output files, what I want to do is just print out the right information to let me make a jump position there. So in 4coder, if I print out the file name colon and then a number and another colon, and the number 1 is always a line number. This number is the line number, so if I put in 1, that'll always reference a real line, the first line. Then it'll let me jump there if I put that in the output. So I'm printing those out, and then when I do this, I can see the files. Let me pull the names up here. I can see the files that are getting generated. So this is the generated type information. Up here we have the handwritten part, and then these token kinds are being generated from the model. Then if we jump over here, again handwritten part and the hash tables, and then finally the actual like implementation. Now this whole file is 5,000 lines of code, so we are kind of generating too much code as our solution, right? Our solution generates too much code, and we want to find ways to reduce that. That'll be a goal. You can see up here 5,000 lines. That's how much it is right now. But again, first I want to make sure this builds. So to make it build, what we need to do is I need the generated Lexer cpp.cpp to be in something that actually is a part of the 4coder primary let's see, build stuff. So I'm gonna stick it right here if I can. Now where is that? Generated, yeah. Generated Lexer cpp.cpp Lexer cpp.h. If I do that, okay. Metadata generator is kind of broken right now too, because it relied on the old Lexer that's not available anymore. And this languages 4coder stuff, I think that can go away. 4coder language cpp.h, yeah. So I'm going to take a quick moment to just say that those files all can be removed actually, because they just don't reference any, they're just not a part of the real way this is working anymore. So those are just going to get deleted. Yeah, that's going to lead to not being able to find them, which is going to mean nothing being able to compile. There we go. Alright, so here we go. We have a build error, and it's directly referencing something that we generated. So, array %d, where is that? Yeah, so this didn't get the memo that it's an array. There's our first fix. And so what we're basically doing here is just going to be tracking down compilation errors and looking at them as if they were bugs in the generator, and then saying, okay, what bug in the generator led to this incorrect output? How would you and how do you go about fixing it, right? So what's the matter here? State label 1, undeclared identifier. I'm not sure I understand. State label 1 is a label. Why should it be a declared identifier? Ah, so this needed a semicolon, and it didn't get one. Okay, so that's again an error in our generator. Fix our generator, run it again, build again the main. Alright, make sure we've reloaded the file. Token list push, identifier not found. Okay, so does that mean token list push never got written, or is it part of something else, or what does that mean? Token list push, where is that? Pretty sure we wrote that. 4coder token.cpp. So I guess what this means is, yeah, the default framework, include, that's what it is. Before it includes hook.cpp, somewhere in here, probably earlier rather than later, we need to include 4coder token.cpp. And, okay, metadata generator also needs that. Alright, so we're going to have problems with unreferenced labels. Basically, any label that no one ever goes to, is going to produce a warning, and we don't want those. So, what we need to do is figure out why we have a label that no one ever goes to. Raw string try quote. That shouldn't actually be possible, because we're simplifying these out as we go, right? So this should have gotten simplified out, but maybe it's possible that it ended up getting optimized out, but didn't get simplified out, if that makes sense. Like, it no longer is reachable, but it is not simplified out of the system. I'm not entirely sure, so what I want to do is switch gears, go back to main.cpp and take a look. So there shouldn't be any states in the model that you can't reach. We tried to write it so that that wasn't possible. Cut fields, cut set. So, I want to right here debug print transitions. And so I gotta pass in a scratch. I think there's one in this scope already. Yep. And I need to pass in a model. I think the model we're using is just called model. Is that right? Yeah. Make our own copy of the model there. So let's take a look at that. And so what we're looking at now is just before we generate the code, I guess that I put those first, which maybe isn't correct. Maybe these should actually go last, after the closes have been successful. Okay, so if I put in some debug prints here, I want to see why raw string try quote. Yeah, so the state machine does in fact say that it has a state called raw string try quote that it never goes to, right? No one is using a go to on the raw string try quote. So let's look at our original model. Nope, not this. This is nothing. Wait, what even is this? I don't even know what that was. Okay, anything called cpp.cpp should... Okay. I think that was an old file, one of the ones we deleted, but I must not have... Yeah, I didn't get rid of these, so... Any other dumb language things sitting around? Yeah. Okay, now everything from language is gone. Moving on. Try quote. So here's try quote. Okay, so the reason we can't reach try quote is because the way we get to try quote is from the delimiter match. Like I said, we're not actually generating that. So I'm going to say let's hold off on fixing it just long enough to see if there are any other hard errors, and then we'll deal with that, because that's just a warning, and we don't want that warning to exist, but the reason that warning exists is a little bit is something we want to deal with in a little bit, right? It's not like what we want to be doing right away. Okay, I'll try this again. End. So there's people calling go to end throughout this code that expect there to be an end label, and there isn't an end label. So debug print transitions can go now, and after everything, but before we return the list, we need to make an end label. Again, that label's no good. Okay, here we go. Alright, and it looks like the rest of the errors are happening in stuff downwind of this. You see what I mean? Like, this is just an error in this code that should say that, right? This is not a part of what we're generating. This is a part of the usage code. Which we're not really dealing with yet. Okay, so we've got through everything except the state label 45. So we're actually almost there in terms of getting this all to build. Let's go back and add that delimiter match thing now, and then we'll be good. So to really do a good job of that, what I need to do is I need to think first if I should be doing type checking, if there's any reason why type checking has to happen first. So there kind of is a little bit of reorganization I wanted to do with this part of the system before I got too far into it. So let's, come on, give me the right CPP file. Let's take a look. So I don't necessarily need to do type checking, I don't think. But I do need to reorganize how the delim match. Where is that? Mark defer delim raw string get delim Lexer one pass last match delim. So here you can see I'm doing like match delim and then fallback peak. I don't actually really want it to look like that. I want the match delim case handler to be the only one in the entire state. And I just want it to have two different transition destinations is what I want. I think that will express what I'm after a lot better. So, because there's not really any way to use this except to always put a fallback peak after it anyway, and that fallback peak is really just trying to specify the second Alright, I'm just not going to support any other feature for matched element except for the one that actually exists, because it's a little bit premature probably. Alright, so the next problem is, you can see right here, I'm putting in case kind delim match, but this whole thing is just not really right. I probably just need to manually construct this one because it's a very different kind of transition from everything else. Like SMI case won't even be able to really do it. So let's just back all the way up to the fact that transition has a destination state for the parent state. Nope, that's not the right place to do it, my bad. The condition is this thing here, right, and so this is where I want to add fail dest state, right? Okay. So upsides and downsides of this idea. The biggest downside is that if I keep it as two separate transitions, then when I'm iterating the whole system to like walk all the destinations, I don't have to look at this, and that might actually be worth keeping this as two separate transitions internally. You know what I mean? Like, if I want to find all the states that are reachable, normally I just have to look at all the dest states, but now I'm going to have to look at all of these and then check what kind of case it is and possibly look at this too. Not loving that feature of this design. Instead, what I could do is just say keep the current structure exactly as it is internally and make it two transitions, but the first one will look like this. So it takes the destination, and the second one will just be an SM fallback, or I guess we'll do it like this. Transition case kind delim match. Why don't I do it that way? Right. So the idea here being that these are two different destinations. I want each of them to be on a different transition so that I can walk transitions like normal and look at the destination states, but I don't really want to, you know, be ambiguous about how I'm marking this. There's a delim match and it failed, and they behave differently, and I don't want to like reuse condition set or fallback for this. I want to put that in there. Okay, so let's make sure that that doesn't like upset anybody or anything. Wait, what's going wrong here? Did I accidentally delete too much stuff? I might have accidentally deleted too much stuff. Let's just undo all the way to the beginning. Okay, we still want this. We still want that. We don't want changes there. We want that. No, we want it. There it is. Yeah, I deleted too much stuff. All I wanted to delete was this. There we go. Okay, so that's building, it's running. Now, hopefully, what we can do is generate the code for that. So somewhere I must be doing special behavior on condition set and not for anything else. Condition node, yep, that's all good. Simplify, merge redundant transitions in each state. Remove peaks, condition is end of file only. Here I'm doing the sorting. And then here, Okay, here's where I'm looking at the rest of the transitions, and you can see I'm not even actually checking, so this is actually slightly wrong, because I'm not checking what kind of transition I have. So the only reason this isn't producing garbage code is because the condition set is probably cleared to 0 on the one that is not a condition set. Right. So basically what I want to do is say all of this logic here is what applies when the state we're in has this type, right? The type that does these types of transitions. So what I really need to do is right up at the beginning when I'm looking at my state itself, I need to go look at the very first transition and figure out what type we have. So state transition kind comes from the transition kind, and then all of this only applies if what we see is that we're looking at a condition set. Now, I don't necessarily want this in here because it's going to start, I don't know, maybe it's fine. It looks like it's starting to get kind of deeply nested. On the other hand, do I really want to separate it out just to avoid that? Not really. So onward, I guess. So we can also see a delim match first. In that case, if we're running type checker, we'll expect to see one of these and one of these, and that'll be the only thing in the entire state. So fail, condition kind, assert the condition kind is match fail, right? Also, if we see anything that doesn't match one of the things we're expecting, that's an invalid path. And the reason we're not actually going to hit any of these asserts is because of the type checker, right? Hitting these asserts means that the type checker failed to find these errors and gracefully avoid them. Okay. So now how do we generate the transition rule for a delimiter matching state? So unlike normal states that break up their behavior into a bunch of possible inputs they could see and determine which state and actions to do based on which input they see, a delimiter matching state doesn't break its input up like that. Instead what it does is it says, when you enter into the state, it begins attempting to match a delimiter that has been marked already in the system. So if I look at our generated code, and I come up here, you'll see I included this earlier, the idea that we have a delimiter first and one pass last, and initially it looks like that. So if you went into the state initially, even without consuming any input, you'd immediately match the first you would immediately match and go to the success case, right? If there is anything in between here, right, then what needs to happen is it'll consume a character and see if it matches the first, and then it'll consume another character and see if it matches one after that, and it'll consume another character and see if it matches one after that. Every time it does that, it consumes a character, and if it doesn't match, then it doesn't consume that character, and it takes the failed transition. If it gets to the end of the delimiter, it reaches this part, and it's consumed all of them, then it takes the success transition. That's the idea. So basically this is a method of letting me implement raw string literals in the C++ Lexer. That's all it's for. But I think a lot of here string type stuff needs similar things, so I decided it should be a fairly generic tool in the system in case other languages, do want to get implemented the same way as this one. later on. So the goal is to generate the code that has that behavior. So let's think through. I kind of want to sketch out by hand what I think that code would look like before I do anything else. So let's change gears here and say that I'm inside my code over there on the left, and it's like you know, whatever the try quote. Where is that? Yeah. So we're label 45. What do we actually want to have happen here? Try quote. Right. Okay. Which kind of raises the interesting question, did we do anything with this? No, that should have just ignored any state condition kind first. Okay, so what I should really have done was said, before we loop over the transitions, take a look and see if the first transition has this property. Because that's enough to determine that we're going to go ahead with the whole loop, supposing that the type checker did its job. Right? Alright, so the next move is we want to sort of sketch out what this code actually should look like. So we have a pointer. We want to see a couple things. So for one thing, when we enter into this, the first, we're never supposed to have the responsibility, or to put it another way, whether or not the person who transitioned into us did a peek or a consume is not really our responsibility to think about. The first thing we need to figure out is how long is this loop going to be, or rather, we need to set up the loop in such a way that if the delimiter is empty, then we immediately take success under every condition without consuming anything. And if it's not empty, that the loop starts working, but that if it hits the end of file, that it will fail, but if and only if it didn't already match everything, right? Basically, at each state, we want to do the following things. One, did we already match the full thing? If so, succeed. If not, can we consume another character? If not, fail. If we can consume another character, peek at it, and if it matches what we're looking for, go back to the top of the loop. If it doesn't match what we're looking for, don't consume it and fail. Okay. So that logic goes something like this. Step one of our loop, I'm going to just write it like this for now, because I'm thinking of it as a generic loop with me controlling the entry points and exits of the loop. Have we finished matching it so far? So we've finished matching it if where we started matching has reached the length of the thing we're after. So what we probably need is something like, before all this started, we have the thing that marks where the delimiter is. We're going to need another thing that marks where we started parsing the delimiter. So somewhere in there that we don't have yet, we need the delim parse first equals input string, right? And then when we come into the state, delim parse first can just equal the current putter. And then what we'll do is say, alright, if the current putter minus the delim parse first, which gives us an integer, plus the delim first equals the delim one pass last, or I guess if I could put it another way, if the length of these two ranges is equal, then we're done, and so we would then want to activate transition for success. So this way, if the delimiter is empty, this will come out as 0, that'll come out as 0, and we'll immediately take the success route no matter what else is going on. If the delimiter has a length of 1, then we have to consume one character to succeed. If it has a length of 2, it's 3, 4, and so on, right? So that seems like a good first step of the logic, because that will get us, that'll finish the logic completely right away if we're on an empty delimiter, and it also is correct for matching any delimiter of any length. Okay, so the second thing we're going to need is how do we continue from there? So if we're not done, I said the next step of the process is, can we even consume another character? So what we want to check is if the putter is equal to 1 past last putter. Now, the delimiter is not allowed to have an end of file in it, so if this happens before we finish, then that's an immediate fail, and so we should do fail. Alright. The next thing we want to do is say, okay, we got that far where we haven't triggered this, if we've gotten this far, therefore we can read this pointer, and we didn't trigger this either, so we still need to read it, so the next step would be take a look at what's in that pointer. And I think we mostly just do that by right in place doing that. So what we're kind of looking at here is we want to do something like this. Actually is probably more important. So we need like the current like parse length to be saved. So this is how far in we've parsed so far. So if our parse length equals the goal length, which I guess we could also hoist out of the loop if we really wanted to. Then what we can do is, if those are equal, we've succeeded. If we are at the end and we haven't already succeeded, then we failed. If we're in neither of those cases, then take a look at what we see at the pointer, and if that matches what we see at the delimiter, where we offset by how far we are into our parse, then we have a success. But we don't have a success that lets us finish, we just have a successful match. So we want to consume that and then loop back around. When we loop back around, we'll get a new parse length and possibly succeed there, or not if we haven't gone far enough. If they aren't a match, then we don't consume it and we do a transition for failure. Okay, so that is how the code needs to get generated. Now that we know how to write the code we're going to generate by hand, we can do the changes we need to make. We can do the correct changes to actually make it work. So I guess first, this was actually not necessary. It could look like this. Furthermore, this isn't even necessary. It could look like this. And then here we'll just have to do this. So we're still actually doing the same amount of arithmetic because we used to be doing a subtraction every step of the loop at the beginning of the loop to find out the length, and now we're doing an extra addition every step of the loop to keep track of the length. But either way, we're still doing the same number of arithmetic operations, so I feel like that's fine. But it has the improved feature that it takes one less register, or one less memory, or one less variable. We have to keep track of one less thing to actually figure out what's going on. So that's a slightly preferred way to do it. And then activating transitions is already easy for us. We just call the action list right like that, right? So do the action list and then do the destination state control flow stuff. And then if the only thing we have to watch out for is if we're in the case where we're at the end of file, then what we need to do is go to end instead of using the transition, okay? Alright, so I think we can do that. Let's write out that code with some code generator. So we need first question, we already have that and the labels. So the braces are in there automatically and the labels in there automatically. So the first thing we need is this. The next thing we need is this. None of this is parametric, as in none of it depends on any of the information that the generator has. This is always how that's going to be structured. The next things we need are this and its counterpart this, which lets us do that. Okay, so inside there we need these separate things. Again, a lot of this is non-parametric, but I'm having it like I'm writing out the generator for non-parametric code just because there's going to be possibly multiple places where this wants to show up, and there's going to be parts eventually nested deep inside of this code that is parametric, and you know, separating that out is kind of a pain. And then we need to activate a transition for success, right? And so doing the same pattern again, that's what we do if that condition gets met. This is what we do if this condition gets met. Alright, this part here, should really write a routine that just like takes code and like just hit a single character or a single 4coder command that would wrap all of this in that, right? That wouldn't be so hard. And it sure would speed up some of this for me. So there's that. Okay, there's this and that. I want to make sure I don't lose track of the structure of all of this while I'm doing it. So, yeah, this else is actually a part of this. Whoops. And this is all like that. Okay, so we get all of this happens, and then activate transition for failure happens right here. Okay, and that's a part of the for loop. Yeah, great. So there's our basic structure. Now we just need to fill in those spots where I left comments, and we should be good. So we want to be able to do this. This comes from no, that's not quite right. So that's doing the field checks on, so we don't actually need that. It's this that we need. My bad. Okay. So here's what's going to go here. This is the end of file version. Gen slow action list control flow. I need to know the activation actions of the delim match transition. I guess I didn't call those transitions before. I'll call this like success transition and failure transition actually. Success transition, failure transition. Okay, so on the success transition we use these activation actions, the ones on the success transition, and we yeah, don't need to do anything else because the go to end, actually this is a failure case, I'm not sure what I'm talking about. Success one is up here, but it doesn't do a go to end. What it does do is more like what this does, go to destination state. Go to destination state, I just need to tell you which transition I'm talking about and you figure it out. Same thing finally again happens down here for failure. Okay, so there we go. So that's what it looks like when we're trying to match a delimiter. We go into this thing here, which does this like looped state that continuously checks a different input, or each input against a different criteria, and its failures go to this transition and its successes goes to this transition here. So hopefully you can kind of see what I did there. I wrote out the logic of how a delimiter match algorithm works, and then I filled in the details from other parts that need to get filled in, kind of like just making a function call saying, in this case do this, except instead of actually making a function call, that's going to write out some code. Right? Oops. Oops, ran the wrong build. Alright. Okay, so yeah, the failure transition was one we want to check. Try to run it, see if everything's okay. Looks like we hit an issue. Okay. Let's debug. take a minute for that to come up. So, how's life? How are everyone out there? I hope you're well. Hope the Visual Studio can figure out how to open up in a minute here. What is going on? There we go. Oh, now it's opening twice. Jeez, come on. There we go. The person didn't show up at all, and the second one made them both show up. Good stuff, good stuff. Alright, where are we crashing? That's the question. So, I asked for the transitions. State is supposed to have transitions. Okay, and this is try delim. And try delim doesn't have any transitions. That's weird. So let me come up here to basically I want to look at the thing where I change how delimiter match gets built out. Seems like that should be enough. That seems like it should be enough. That's all I really have to say about the matter. So yeah, try delim here should be getting both of these. Why isn't it? We're going to need to look at that. 1424. Something about the model declaration isn't even making sense right now. Either that or there's like an optimization somewhere that is trampling this information later. So I come in here, raw string try delimiter, okay, so I do see one issue right away. What now? Weird. Okay. So imagine it comes in here, it makes the new transition. It doesn't actually stick its kind in there properly, but the rest of it actually looks fine. The state called raw string delim has its transitions, they look good. So I have another theory about where these are disappearing to, but I want to fix that thing we just saw first. So right here we just want to throw in real quick that if there's a fail, then do the fail. In fact, we could just let's just go ahead and say that if we see a kind that doesn't match one of the special kinds, that we're going to do this rule here. Okay? Alright, so our next move is figuring out where actually, because that was a problem, but that wouldn't explain why we saw no transitions, because what we just walked through showed us actually seeing transitions. So I'm going to go out on a limb and say maybe this has to do with the fact that we're copying a model, and see if that has anything to do with it. So if I look at the model before the copy, and it's going to take a minute, but let's walk through the states and see if we can find one that has the right pretty name. So op stage, we're going to see a lot of those if we go this way. I can't even go through it that way though. Just going to grab one of these. Keep going. We're looking for one whose pretty name is about delimiters, and then we'll pay a little bit more attention to which thing is which. Let's see, none of that. Whoops, not like that. Give me that. No, I said not like that. What do you... Can you focus? I want this. Thank you. Stringscape. So we're getting into string stuff, which is closer. I want to find raw string stuff. String escape. 4, 3, 2, 1. Raw string get delim. This is pretty close to where we want to be. Raw string find closed. Raw string try delim. Okay. Let me grab that. Raw string try delim. Here it is. So right now it has 2 transitions in it. Right? The kind of the transitions are still wrong, which is bad. But I just want to figure out why they're disappearing. These must be activation actions that they received up from their downstream or something like the state or something like that. I'm not sure what that is. But I'm guessing after I do the model copy, that we're going to lose those transitions. No, this still says it has 2 transitions. Okay, so what I just did was, because the expression here is based off the model, and I copied the model and put it into the same variable, the same number of steps through the linked list finds it again. So you can see I'm still looking at raw string delimiter here, and the transitions still exist. And they still link up to try quote, and that's correct. And what is this one linking up to? Try delim. Wait, that shouldn't go straight back to try delim. I have to look at that, but anyway. The point is, somewhere along the way we lose that information, and I want to figure out where. So here it is right here. Got it. Oh boy. 3156. So I went through the trouble of saying only run this operation if we see that we're in the right kind of condition type, if the state is using the right kind of condition type, but I didn't actually make sure that it only replaces the list in that case. So it was zeroing out the list for anything that didn't have that type. Okay. Wrong build. Generate off of that. Okay, so that's good. Now the generator runs, and I want to see try delim. Cool. So now when we try delimiter, it's doing this loop here: delim length, parse length, just as we had it right out. So make sure all that builds, And so I can see here that the first thing it's hitting is outside of this file. So it's all building. It's all building. Now what we want to do is figure out if it's working. That's going to require a little bit more putting stuff together. I don't think we can do that just out of nowhere. So let's take a look at what we would have to do. Probably we're just going to want to build not there. Build a little test case and switch this over to like F4 being my, so if I build run generator, I probably want something like this for now. Get rid of you. Build token tester, run token tester. Right? And I'm just going to stick those down here at the bottom and say we need to build those out. Build token tester. It's going to look like this pretty much. I don't actually need the run token tester. That can just be on F5 as well. So what I'll do is I'll say let's scrap this for a minute and rearrange our options here. So we're going to have build C++ Lexer generator, build token tester, run generator, 1, 2, 3. Generator. So the question is, what does the build generator batch script actually do? I think it's just, yeah. Source file relative path to the start of the Unity build for generator. I think this will actually just work. I don't think this actually assumes anything about it being a generator besides in name. I think it's only nominally for generators, but really I could just build anything with it, right? So then I can just do 4coder. I'm going to put this all under the languages folder that we've just cleared out. Yeah. Languages, 4coder, cpp.cpp, Lexer cpp test.cpp, and I kind of want to say that the generated stuff should also go into languages. So before why don't we say let's finish that up next episode, and let's clean up this episode with the following moves. So first of all, I can hit F1 to do that and F3 to do that. Now I want to come over here and look at where I'm outputting these files and say, can we change our output destination in one little way by saying put these out in languages. And I guess I'll just use a / and it'll figure out what I'm talking about. Languages / that stuff. Because that's gonna of course, this will only work if the languages folder exists now, which is annoying, but we can just work around that with scripts. Also, that won't work anymore. So here's a question. Do I have path to self? So if I want this to work, what I'm actually going to have to do is I'm going to take the path to self and path to source it by removing another folder. Path to self. If I take one more folder off of it, I'm at the root of the 4coder code, and then I can do push U8 string f here onto an arena. Okay. See if that rolls. Okay, so now it can load these, and it puts them in the languages folder, which is good. I don't really mean to close my copy of the folder over here. I want to get rid of the old generated files now. And where are they? Where are they? Should be below all the 4s, shouldn't they? I guess they're below most things. There they are. Generated are out, and now they are living here in the languages folder. Cool. So there we go. If I look at my old versions of the generated files, they have just been deleted, which is good. So now I have these living in the languages folder, and the cool thing about that is that means I can also stick the test for them right there with them. 4coder Lexer cpp test.cpp. Alright. There we go. And that will look a lot like this. Who here brought in standard IO? I guess you did, didn't you? Okay. It's weird because I didn't actually include standard IO manually anywhere in there. Did cpp.cpp include standard IO or something? No, not that one. No. Well, I feel like it probably should be explicit right there. Just because. You know, I think it's only coming in because string f brings it in right now, but that might not always be true. So there we go. That's kind of what I wanted to get started, is just get a little hello world in there for this new program. And there it is. Okay, so we now have the framework in place, the structure in place to build a test for the Lexer. I think it's compiling. We know that it's compiling. I think it's fully up and ready to be tested. I don't think there are any features that that I know are in there that haven't been implemented. Let me do one other thing, which is I do want to fix all the code that got broken when I'm in the main 4coder project when I moved these generated files into the languages folder. And there we go. Everything's back to where we had it, and we are all set to start. Hold on, F1, F3. So if I hit F1 and F3, I get this. If I hit F2 and then F3, I get this. Awesome. We're all set. Next episode, we can build a tester. See you then.